Hello. So, am I audible to all? Okay. So, we'll wait for a few minutes only. Okay. Hello. So, good afternoon, everyone. In last lecture, we have seen the Biot-Savart laws applications, right? So, we have seen there are three applications. That is, we are using this Biot-Savart law when we want to find the magnetic field intensity due to infinite uh, filament. Second was due to finite filament, and third is due to circular ring, right? So the last one we were seeing there, that time half one we solved. So we'll see the remaining half part here. Okay. So just wait, I'm sharing screen here. Okay. So I hope the screen is visible to all. So we have seen this magnetic field intensity caused by circular current loop, right? So uh, we have to, while finding any application, we are using here the Biot-Savart's law only. That is, we are using equation dH bar is equal to I dl bar cross A bar R divided by 4 pi R square. So this equation is important, and according to the filament which we are using, that can be infinite filament, finite filament, or circular ring. So you should first recognize that, and where you are finding the magnetic field intensity. So according to that, just find this dl bar and A bar R, and then you can put all these equations in all these values in the equation of this dH bar. So here we find yesterday you've seen up to this point, that is dH bar is equal to, when we put all magnitudes of this A bar R, dl bar, and R square, so we are getting this equation. So dH bar is equal to IR d phi A bar phi. This is cross sign into bracket minus R A bar R plus Z A bar Z divided by 4 pi into bracket R square plus Z square raised to 3 by 2. Right. So here uh, very few students join here. So let's wait. I'll put message. Okay. So yesterday told you to solve this equation and tell me the answer. So if anyone solve, can you tell me the answer? If anyone solves this example, means you not solve, not tried. What will be the cross product of this A bar phi and A bar R? Okay, then now tell me. So here we have to just multiply or take the cross product, right? Means we have to multiply in this bracket only. So we'll first multiply by this term to this term, that is minus r into a bar r. So when we are taking the cross product, okay, so other multiplication will remain as it is. Okay, so and we are taking the cross product of only unit vectors, right? So the term will be, write down there, I r d phi into minus r. So you can directly write this as minus I r square d phi. Okay, minus I r square d phi into bracket. Now the cross product of this a bar phi and a bar r will be there. So just tell me, what is the cross product of a bar phi and a bar r? A bar phi cross a bar r. What is a bar phi cross a bar r? Anyone? Yesterday I told you how to take this cross product, right? By going in clockwise direction, anti-clockwise direction. So what is a bar phi cross a bar r? Tell me fastly.
Minus a bar z.
Minus a bar z. Snehal, roll number 30, Snehal. Is this correct? Yes, you are not audible.
Hello.
Yes. A bar phi cross a bar r. What is the answer? Cross product.
Minus.
Minus. Yes, it is minus. Okay. So minus a bar z. So why it is? So when you are going in clockwise direction, that time the direction is r, phi and z. Now we are coming in reverse direction, that is phi to r, right? R, phi and z is there. And now here we are not coming as r to phi. We are coming as phi to r, right? Now after phi there is r, means you are going in anti-clockwise direction. So when you are going in anti-clockwise direction, the sign should be negative, right? So the sign is negative, that is minus a bar, and the third vector is z. Okay, so it is minus a bar z. So what the first term will become? The first term was minus I r square into d phi, right? So minus minus will become plus. Okay, so it is plus I r square d phi into the cross product of unit vector is a bar z. Okay, so you can see here this term. So here I is taken common. Okay, I is taken common, and the first term is here r square d phi into unit vector a bar z. Okay, a bar z is there. Now we'll see for the second term. Okay, again here I r d phi, right, into unit vector a bar phi cross this z into a bar z. Now we'll take the cross product of only this a bar phi and a bar z. So take the multiplication as I r z d phi will be as it is. Okay, into a bar phi cross a bar z. So what is a bar phi cross a bar z?
A bar.
A bar
A bar
phi,
r.
a bar r. Correct. Okay, the remaining term, that is a bar r, and it is plus because the sequence is right here. Okay, after phi this z is coming, therefore unit vector a bar r. So what will be the term? I r z d phi into unit vector a bar r. Okay, so here I is taken common, that's why it is r z d phi a bar r. and the denominator will be as it is. Okay. So I hope everybody got this. You have to remember for the cross product only that clockwise and anti-clockwise directions. Okay. Now here this R term, that is A bar R term, is getting cancelled here because we are going in radial directions. Okay. A bar R. So I'll show you here. Okay. So just see this figure here. So, this is center of your loop, right? This one is one circular loop, right? And this origin is nothing but the center. So when you go in all directions, okay, when you go in all directions, everywhere the radius is same. Okay, at each point of this filament, the radius will be same from the origin, right? So everywhere there will be component of this radius r, right? And the unit vector in direction of that radius is nothing but a bar r, right? So if I consider that one vector is suppose in y direction, okay, in plus y direction, okay, from origin to this point, the radius is r. The unit vector in direction of that radius is a plus a bar r. Similarly, if I go in this negative y direction, okay, if I go in the negative y direction, again up to this point, the radius is r, right? Radius is r, and the unit vector in that direction is minus a bar r, right? Now, in one direction, it is plus a. If it is in opposite direction, then it is minus a bar r, right? Means what happens actually, so when we are considering the radial components of this filament, that time they get cancelled. Okay, they get cancelled. That's why the a bar r term becomes 0 here. Okay, the a bar r term becomes 0. So here it is given by symmetry, the contribution along a bar r is 0 because the radial component is produced by a pair of current element 180 degree apart cancel. Okay, so whatever be the radial components produced in the direction of a bar r, they get cancelled there. Okay, so if this term becomes 0 here, okay, this term a bar r term becomes 0. So what will be the remaining quantity? Remaining term will be only I into r square d phi a bar z divided by this 4 pi r square plus z square raised to 3 by 2. Okay. Now we have to find this h bar. So h bar is equal to integration of this dh bar into unit vector a bar z. So we'll take directly. Now here the variable is your phi. Okay, we have to take integration with respect to phi. And how the phi is varying? The angle phi varies from in cylindrical coordinate system. The angle phi varies from Rushali. Yes, anyone? How this angle phi is varying?
0 to 2 pi.
0 to 2 pi. Correct. So this phi varies from 0 to 2 pi. It starts from x-axis and it ends at x-axis only. And this angle is along positive z-axis. Means everywhere this angle is same on this z-axis. Okay. So we are taking limit from 0 to 2 pi. Okay. So the term is as it is here. Now integrate here, the variable is only phi here. So it is I r square divided by 4 pi r square plus z square raised to 3 by 2 into this a bar z will be a constant here, and integration from 0 to 2 pi of this d phi. So integration of d phi is from, and the limits are from 0 to 2 pi. So it is 2 pi minus 0, simply 2 pi to 4 pi. So in denominator, only 2 term will be there. Okay. So it is I r square a bar z, okay, divided by 2 into bracket r square plus z square raised to 3 by 2. Okay, so this is your final equation for the h bar, and this is due to what? Which type of filament this equation is getting? By which type of filament? Yes. Which type of filament is this? Finite, infinite?
Infinite.
No, it's not
Finite,
infinite.
finite, sorry.
No, not finite also. This is circular ring. Okay. Circular ring or circular loop, you can say. For infinite, we are taking limit from minus infinity to plus infinity. Remember, this equation is different. For finite, we are taking limits from A to B, right? There are angles alpha 1 and alpha 2. We are getting equation in terms of sine alpha 1 and sine alpha 2. Remember. And this is for closed loop or circular loop. Okay. Filament म्हणजे काय? तर एक single wire, conducting wire is there. Okay. So according to its length, means finite, infinite, and circular ring. So there are different magnetic field intensities. So we derived 3 equations here, and out of these 3, one equation is compulsory in examination. Okay. So any doubt in these equations? Any doubt?
हॅलो मॅम
Ha, yes.
हॅलो
Ha, yes, yes.
ते क्रॉस
हा?
प्रोडक्ट पासून सांगा की रिपीट
Cross
एकदा सांगा की क्रॉस प्रोडक्ट
Okay,
पासून
okay. Ha, yes, yes, yes. So, for this cross product, so you just write down here in your notebook a bar r, a bar phi, and a bar z. Okay, and go in clockwise direction. Go in clockwise direction. Okay. So when you are going in clockwise direction, so what is the cross product of a bar r and a bar phi? A bar r cross a bar phi?
ए बार झेड
A bar z. A bar phi cross a bar z?
ए बार आर
A bar r. And a bar z cross a bar r?
मायनस ए बार फाय
A bar z cross a bar r. You are going in clockwise direction, na only.
A
हाँ.
bar phi.
A bar phi.
Phi.
Correct. Right, na? Now, just see here. You just concentrate on these unit vectors only. Just don't concentrate on these other terms. Okay. So, now tell me, here cross product of a bar phi and a bar r is there. Right, na? Now just see, where is a bar phi and a bar r? Go in the sequence only. Take a bar phi cross a bar r, and just tell me you have to go in clockwise direction or anti-clockwise direction?
अँटी क्लॉकवाईज
Anti-clockwise direction. Then when you are going in anti-clockwise direction, sign is plus or minus?
निगेटिव्ह मायनस
Negative. Right. Now, a bar phi cross a bar r means sign is negative. Then what will be that unit vector? Minus a bar. The remaining vector will be there, na? Right? A bar
Yes.
phi इथे आहे, a bar आर इथे आहे, म्हणजे राहिला कोणता वेक्टर? ए बार झेड, राईट? ए बार झेड असणार आहे. ओके, just wait. I'll share one PPT here, and then I'll show you. Okay. So screen is visible, right? Na?
Yes.
Now just concentrate. Okay. Concentrate here. So here is A bar R, okay, A bar phi, and A bar Z. Okay. Now go in clockwise direction first. Here A bar R cross A bar phi plus A bar Z. A bar phi cross A bar Z plus A bar R, right? And A bar Z cross A bar R plus A bar phi. इथपर्यंत काही डाऊट नाही ना? नाही आहे
No.
ना? Then A bar R, A bar phi, and A bar Z. Okay. Now go in anti-clockwise direction. Okay. So A bar R cross A bar Z. R cross A bar Z. The third term, na? Third term, that is A bar phi. Right? Okay, A bar phi. But the sign is minus. Or you can go in clockwise also. Or you can consider as A bar R cross A bar phi as A bar Z. Okay, A bar Z. But the sign is minus. Okay. Then A bar phi cross A bar Z is A bar R, but the sign is minus. Okay. Or here also, here only, if you understand, then it will be better, because here you understand this concept. Only what you have to do, just to check from where you are going now in this, in our equation, how we are going. A bar phi and cross A bar R is there, right? Na? A bar phi cross A bar R. Now just check here. A bar phi and cross A bar R means we are going in reverse direction, right? Na? If we are going in reverse direction, only the sign should be negative here, right? That is unit vector minus A bar Z. समजलंय का?
Yes.
So it is minus A bar Z. Wait, I'll share the screen once again. Oh, yes, visible. Okay, so A bar phi cross A bar R is plus A bar, sorry, it is minus A bar Z. Okay, so again one minus sign is there. So what the term will become? It is I plus I R square d phi into unit vector A bar Z. Okay, so here I is taken common. So it is R square d phi A bar Z. This is the answer of first term. Okay, similarly you can find for the second term. Now here again take the cross product of A bar phi and A bar Z. Now tell me, what is A bar phi cross A bar Z? A bar phi cross A bar Z. Yes, go in the sequence. Yes, sir. Hello. So what is phi cross Z?
A bar R.
A bar R. Then it is positive or negative?
Positive.
positive because we are going in the sequence. Remember only R, phi and Z. R, phi, Z. Okay, now here after phi there is a Z. Means the answer should be positive, and the third component, that is A bar R here. Okay, so the term will be I R Z d phi into unit vector A bar R. Okay, R Z d phi into A bar R, and I is taken common here. Okay, now this A bar R term get cancelled here. Means this whole term get cancelled. Why? Why this is? Because here we are considering one circular loop, right? One circular loop. So when we are going in all directions, everywhere there is a radius, and everywhere there is unit vector going in all directions. That is the A bar R. So if I consider one positive direction, the unit vector in that direction is plus A bar R. And if I take the opposite one, the unit vector will be minus A bar R. So what happens? Thus, by this symmetry, and because of this symmetry, what happens? These components get cancelled, means plus A bar R and minus A bar R. So if you add this, the actual component becomes 0 here. That's why it is given that by symmetry, the contribution along this A bar R becomes 0. Okay, because they are 180 degree apart from each other and they get cancelled here. Okay, so if this A bar R term becomes 0, so what will be the remaining term? I into R square d phi A bar Z divided by 4 pi into bracket R square plus Z square raised to 3 by 2. Okay, now here we are getting this term as dH bar. Now we have to find H bar only. So for finding H bar, we are taking integration. So take integration of this term. Now here we have to integrate with respect to phi, right? So here the changing quantity is only phi here. And we know that when we are considering the cylindrical coordinate system, so there are 3 coordinates, right? R, phi and Z. Now your radius is varying in cylindrical coordinate system. Radius is varying from
0 to
radius
infinity.
0 to infinity, correct. Radius cannot be negative, so it varies from 0 to infinity. Your angle phi varies from 0 to 2 pi, and the component Z varies from minus infinity to plus infinity. Okay, so as the variable is here phi, so that is varying from 0 to 2 pi. So we are getting the limits here. Okay, now here all others are constant. There is no any phi term. So we are taking this outside and just integrate from 0 to 2 pi of this d phi. So integration of d phi is phi. Limits are from. Okay, so just it is 2 pi minus 0. So pi get cancelled. 2 by 4, it is 1 upon 2 simply, and all other terms as it is. Okay, so the equation we are getting it as I R square A bar Z divided by 2 into R square plus Z square raised to 3 by 2. So this is the final equation for the magnetic field intensity due to circular current loop. Remember, due to circular current loop. So we obtained such 3 equations. First was due to infinite filament. Due to infinite filament, that equation is here. Remember this H bar is equal to I upon 2 pi R into unit vector A bar phi. Remember these equations because they can ask you examples also from this equation. Okay, so for infinite filament, it is only I upon 2 pi R unit vector A bar phi. Okay, then for infinite filament, for finite filament means when a particular length of that filament is given, that is from A to B, that time the equation is H bar is equal to I upon, here it is 4 pi r into bracket sine alpha 2 minus sine alpha 1 into unit vector A bar phi. Remember, the unit vectors are same for both, that is A bar phi. Here we are taking angles for the lower end and upper end. Okay. And the third we have just seen, that is for the circular loop. The H bar is equal to I r square divided by 2 r square plus z square raised to 3 by 2 into unit vector is plus A bar z here. Okay, and the unit is remaining, unit is ampere per meter. Always write the unit. Okay, समजलं सगळ्यांना derivation?
Yes.
Okay. Now we'll see one more important point, that is the ampere circuital law. Just like Gauss law, it is also asked in examination. So here one more point is there. So when we are considering this z is equal to 0, okay, actually we are finding this magnetic field intensity at point P, right? At point P means they are having some coordinates. But if we consider that this point P is located at origin only, okay, at origin only. Imagine that circular loop. Okay, that circular loop is already in x and y plane, right? And again we are considering that point P where we have to find that magnetic field intensity. That point P is nothing but your origin. So this H bar at origin 0, 0, 0 can be given as, if we are considering origin r radius r phi and z coordinates, means if z is equal to 0 there, if z is equal to 0, so this equation becomes as I r square divided by 2 into bracket r square plus z square. Okay, so z term is 0, r square plus z square raised to 3 by 2. So it is r raised to r square raised to 3 by 2. So if you solve this equation, you are getting this as I upon 2r into unit vector A bar z. Means here we are considering as z is equal to 0. Okay, z is equal to 0. So all other terms will be as it is. Okay, because we are getting this as a final equation. This as final equation. So all other terms will be as it is. Only we are considering here z is equal to 0. Okay. So at the origin, the magnetic field intensity will be I upon 2r into unit vector A bar z, or hz is equal to I upon 2r. If it is asked, then only you can write this equation. Now we'll see the important point, that is Ampere's circuital law. So it is just like a Gauss law. In Gauss law, we can find the charge, right? No? We can find charge Q is equal to closed surface integral of d bar dot ds bar. This is the integral form of Gauss law. So Q is equal to psi is equal to closed surface integral of d bar dot dl bar. And here, instead of that charge, we are finding here current. Okay. So this Ampere's circuital law states that the line integral of magnetic field intensity. Okay. Magnetic field intensity is H bar. So the line integral of this magnetic field intensity about any closed path, is exactly equal to the direct current enclosed by that path. Okay. So the line integral of this magnetic field intensity, that is H bar, about any closed path. That's why this circular symbol is there. About any closed path is exactly equal to the direct current enclosed by that path. Means in mathematically we can write it as the closed line integral of h bar dot dl bar is equal to current I, and this current I is measured in ampere. That's why this closed line integral of h bar dot dl bar is also in ampere. Okay, now here we are considering one conductor through which the current I is flowing, and when current I is flowing, that time you can consider the different closed paths. Okay, different closed paths means the what is that current flowing? That current flowing is equal to the closed line integral of this h bar dot dl bar. Means whatever be the magnetic field intensity produced by that loop is nothing but or is equal to the current I. Right? Now here the closed path can be of any shape. Okay, but it should be closed one. It should be closed one. Then and then only the current will flow. Okay, so A path is there, B path and C path, but all are closed one. Okay, all are closed. So remember the statement. Then we'll see here the verification of Ampere circuit law. Okay, so we know the Biot-Savart's law here. The Biot-Savart's law is given by h bar for infinite filament. Here we are considering the infinite filament, right? We obtain three derivations for infinite, finite, and circular loop. Okay, so when we are considering an infinite filament which is placed along z-axis, whose length is from minus infinity to plus infinity. So for that, the Biot-Savart's law is given by h bar is equal to I upon 2 pi r into unit vector a bar phi. Okay. Now, and dl bar. Actually, we have to check here this law. That means we want here h bar and dl bar. So h bar we have for infinite filament, and dl bar we have to find. So dl bar is equal to r into d phi a bar phi. Now how it is? Because here we are considering the closed path, right? Now we are considering one closed path. So what is given? This magnetic field intensity. Okay, the magnetic field intensity over a closed path. So that can be of any shape. So when we are considering one closed path, so for that, this becomes one arc. One arc. Okay, it is not a straight line. We are not considering here one line conductor. Okay, it is a straight line, right? It is an arc. So for an arc, that is nothing but the length. So that length or arc is nothing but radius into angle, right? Radius into angle. So it is r into d phi, and when you are going in this direction, the unit vector is a bar phi. That's why this dl bar is r into d phi a bar phi here. Okay, a bar phi. So here this h bar dot dl bar is given by line integral of h bar is I upon 2 pi r a bar phi dot this dl bar is r d phi a bar phi. So r and r get cancelled. A bar phi dot a bar phi is equal to what is a bar phi dot a bar phi?
1.
1, correct. It is equal to 1. So it is I upon 2 pi, only d phi will be there. Okay, so here this is closed line integral of h bar dot dl bar is equal to, here variable is phi here, and the phi is varying from 0 to 2 pi. Therefore, integration from 0 to 2 pi of this I upon 2 pi into d phi. Okay, so this I upon 2 pi is taken constant outside. So integration of d phi is phi, and phi is varying from 0 to 2 pi. Therefore, it is 2 pi minus 0. So this 2 pi and 2 pi will get cancelled, and you are getting only I. So here the Ampere's circuital law is proved, that is closed line integral of h bar dot dl bar is equal to current I. Okay. So in examination, they are asking you simply state and explain Ampere's circuital law, or state and verify Ampere's circuital law. Okay. So these questions are there. That time you have to write this Ampere's circuital law. Okay. Now this point is important. So समजलंय का Ampere's circuital law? Okay. Are you referring notes? पाहिलं का notes सगळ्यांनी? Yes. Anyone referred notes or still not? I think no one referred, right now? Yes, right? Okay, if anyone have referred, so can anyone tell me, are you getting? Yes? Okay. Now we will see the important point which is asked in examination many times, that is the application of this Ampere's circuital law for unsymmetrical surface, or it is also called the point form of Ampere's circuital law, right? We have seen in first section the Gauss law, right? And there was point form of this Gauss law, that was also the application for the unsymmetrical component, right? So here for finding the point form of this Ampere's circuital law, we are considering here one closed loop. Okay, concentrate, this is important. So consider one closed loop here, A, B, C, D, A. Okay. So here we are going in anti-clockwise direction, and this loop is placed in the Cartesian coordinate system. Okay. Now, if you refer this all axis, then you can see here that when I consider path A to B, okay, path A to B, or when I consider this distance, that distance is parallel to y-axis, parallel to y-axis. Therefore, the differential component or differential length of this AB is nothing but delta y. Okay. So for path C to D or for path D to C, both this length is also delta y. Okay. AB is equal to CD is equal to delta y. Similarly, if you check path B to C and D to A, okay, means the differential lengths for these. Now these two lines are in the direction of x. Okay, these two lines are in the direction of x. That's why the differential length is delta x, or the small length is delta x here. Okay, and now we have to consider one central point, that is P, where we are finding this h bar. Okay. So the h bar, that is magnetic field intensity at point P, okay, at point P, or at the center, is given by this h bar is equal to hx0 into a bar x plus hy z0 a bar z. Now any vector can be written as, if I consider vector a bar, that can be written as ax a bar x plus ay a bar y plus az a bar z. Similarly, you can write this vector h bar also. But as we are considering the central point, here we are using the suffix that is 0. Okay. Then we have to similarly write equation for j bar. This j bar is nothing but the current density. Okay. This j bar is nothing but current density. So this j bar is equal to jx a bar x plus jy a bar y plus jz a bar z. Okay. Now we have to find the closed line integral, right? We have to find the closed line integral. So the closed line integral of this h bar dot dl bar means for that loop actually we have to find, right? So the closed line integral of this h bar dot dl bar is nothing but we have to split this into different sides, that is a to b, b to c, c to d and d to a, right? There are 4 sides and according to that we have to split this closed line integral of h bar dot dl bar. Okay. Then we have to find now one by one. We have to consider first a path a to b. Okay, consider path a to b here first. So for path a to b, h bar dot dl bar is equal to, now h bar for path a to b, h bar dot dl bar we have to find. So anyone tell me what will be the h bar for path a to b? Any vector is equal to that vector divided by its any vector is equal to its magnitude into direction. So what will be h bar for a to b path? Yes, anyone? Hello, anyone? For path a to b, in which direction you are going? In which direction you are going?
A bar y.
A bar y, right? A bar y. Means it is plus a bar y. Okay. So h bar can be written as hy into plus a bar y. Okay. And for length, that can be, you can take the positive unit vector. Now here dl bar can be given as the differential length is delta y. Okay. So it is delta y into a bar y that you can take. Okay. So this for path AB, h bar dot dl bar is equal to hy a bar y dot, and remember here it is dot product. Okay. So dot delta y a bar y. So a bar y dot a bar y is equal to 1, right? So the remaining quantity is only hy into delta y. Okay. Now here we have seen in first section while solving this Gauss law, point form of Gauss law, how these terms are coming. So this hy constant term can be written as it is equal to hy0. hy0 means what? It is at point at the center of that loop. Okay. This hy0 is nothing but the y component of this h at the center plus now here it is da by hy upon da by x, means what? It is varying with x. This hy is varying with x. Now how it is varying with x? That hy means this is along this y-axis, right? Along the y-axis. And why we are taking this x? Because we are taking from point P to this AB. Now, when we are finding any distance, or when you are referring this point P and this line AB, that time you are going in x direction, right ना? इथून इथपर्यंत आला म्हणजे कोणत्या डिरेक्शन मध्ये गेला तुम्ही? तर एक्स डिरेक्शन मध्ये, बरोबर ना? एक्स रेफर करताय तुम्ही. तुम्ही ज्यावेळी ए टू बी पाथला जाणार त्यावेळी कोणती डिरेक्शन आहे? तर वाय डिरेक्शन. पण जेव्हा तुम्ही पॉइंट पी पासून या पाथ ए बी पर्यंत येत आहे तेव्हा तुम्ही कोणत्या डिरेक्शन मध्ये जाताय? तर एक्स डिरेक्शन मध्ये. ओके, मीन्स दॅट इज चेंजिंग विथ रिस्पेक्ट टू एक्स. विथ रिस्पेक्ट टू एक्स, दॅट्स वाय इट इज plus means that hy is changing with respect to x. So it is plus dabba hy upon dabba x into it is delta x upon 2. Then why it is delta x upon 2? Because if you consider this point P, it is the distance from point P to this path AB, to the path AB. Now the total distance from B to C is delta x. Now point P is located at center, means at exact half. So the distance from point P to path AB or this line is nothing but delta x upon 2. Okay, so that is the formula. Here first you have to write the central by considering center, that is hy0 plus dabba upon dabba x. It is changing with respect to x. That's why dabba upon dabba x of this hy into the distance from point P to that line, that is delta x upon 2. Now we have to put this in the equation. That is the line integral from path A to B of h bar dot dl bar is equal to hy into delta y. Now what is hy? Hy is hy0 plus dabba upon dabba x of this hy, then delta x upon 2 into again this delta y. Okay, so हे समजलंय का?
Yes.
Okay. Similarly, you have to consider path B to C. Okay. So when you consider path B to C, so just tell me what will be the h bar dot dl bar. What is h bar? H bar. You are going in which direction? From B to C, you are going in which direction? X या Y? X direction. So that direction is plus या minus? Positive x axis या negative x axis? Yes?
Minus.
Minus, correct. So this h bar will become minus, or we can write this as hx. Hx into unit vector minus a bar x, right? Na? We are considering the reference as x here. So it is hx into unit vector will be minus a bar x because we are going in negative x direction. Okay. Then what will be the dl? For dl, don't consider any direction. You can take it as a plus only. Okay. So dl is nothing but the differential length. Okay, differential length here. So it is delta x into, you can consider there the plus unit vector, that is plus a bar x. Okay, so for path B to C, here the equation will be the closed line integral for path B to C of h bar dot dl bar is equal to hx. For this h bar, it is hx into unit vector a bar x dot this dl bar is delta x into unit vector a bar x. Again, if you take the dot product of this a bar x and a bar x, it is equal to 1. So it is equal to minus hx into delta x. Now again we have to write equation for this hx. Okay. Now this hx is equal to hx0, that is at the center point P, plus now this hx is varying with respect to y. Okay, this is path B to C. Now we are going from point P to path BC. So when we are going in this direction, that time we are finding it with respect to y, means it is dabba hx upon dabba y into the distance from point P to this line, that is path BC. So what is distance from point B to path BC? पॉइंट पी पासून या बीसी पर्यंतचा डिस्टन्स किती आहे? Yes, what will be that distance? Yes, Suraj.
Delta y by 2.
Delta y by 2, correct. Because the total distance is delta y and we are considering distance from point P to this BC. Okay, that is delta y divided by 2. Okay, so it is delta y upon 2 and it is changing with respect to y. That's why it is dabba hx upon dabba y. Now the equation is for path BC, it is minus hx into delta x. So put this, the for path BC, integration of this h bar dot dl bar is equal to minus hx delta x. So hx is minus into bracket this term as it is into delta x. Okay. So similarly, find for path CD and for path DA. I think we'll see that in next lecture because today many students are absent here. Okay, so we'll see the remaining part in next lecture because the remaining students will also understand how to take this. Okay. So tomorrow we'll finish this Ampere circuital law application and after that we'll see the examples. So from this chapter is important as for means the whole question, the whole 16 marks question is asked from this chapter only many times. Okay. So means they are asking you minimum 3 questions from this chapter. Minimum 3. Okay. 3 to 4 questions can be asked. So in that, I'll tell you. And for EME, fixed questions are there. That is from this chapter, Biot-Savart's law, then examples, applications, Ampere circuital law, these applications. So the questions are fixed, but almost it is covering all. But if you do at least fixed questions, you can easily pass and score also. Scoring is also possible in this EME if you take this subject seriously. Okay. So if you have any doubt, anyone can ask me. If any doubt is there. आहे का काही डाऊट कोणाला? Okay, so if no, we'll stop here. Thank you all and have a nice day. Thank you.